Have you ever just looked up at the night sky and really wondered what our solar system actually looks like? Well, today we're going to explore the anatomy of that celestial void, but maybe not in the way you're expecting. So, stick with me on this. Let's start with a really cool thought experiment. Imagine we have this giant cosmic blade, and we can just slice our entire solar system right down the middle. Kind of like a birthday cake. What would we actually find inside? You know, the picture in our heads, probably from school textbooks, is this neat little lineup of planets. But the reality? Oh, it is so much stranger and, honestly, a whole lot emptier. So, for real, what would we actually see? To get to the bottom of this, we have to start right where all the action is, at the absolute center of it all, with our one and only star, the sun. And right away, you're hit with this just mind-blowing fact. The sun isn't just the biggest thing around here. It's practically everything. A staggering 99.8% of all the stuff, all the mass in our entire solar system is in the sun. Everything else, every single planet, every moon, every asteroid, it's all just the leftover 0.2%. Just cosmic crumbs. I mean, the scale is just, it's almost impossible to wrap your head around. You've got the sun, this massive, churning ball of hot plasma, and then you have everything else. By comparison, even a giant planet like Jupiter is basically a speck of cosmic dust, just caught in the sun's incredible gravity. So, we've got that straight. The sun is enormous. Our slice would definitely cut right through it. But, that brings up the next big, obvious question as we start looking for the planets in that very same slice. If the sun is pretty much the only thing we're guaranteed to hit, then where are all the planets? And here it is. This is the big twist. If you were to take that slice through our solar system on any random plane, the odds are overwhelming that you would see absolutely nothing. Just the sun in the middle and then endless, empty space. How is that even possible? Well, it all comes down to this one single concept that our brains are just not built to handle: cosmic scale. The planets themselves are unbelievably tiny when you compare them to the vast emptiness that separates them. Okay, try this analogy because it really helps. If you shrink the sun down to the size of a basketball, Earth wouldn't be a marble or even a pea. It would be a single grain of sand. And that grain of sand would be about 25 meters or 82 feet away from the basketball. Now, what are the chances your giant cosmic slice is going to hit that one specific grain of sand? So you can see the problem. The inner planets, that's Mercury, Venus, Earth, and Mars, they're just these tiny little rocky targets in a huge three-dimensional void. The probability of your slice hitting one of them is just astronomically small. Sure, you'd see solid rock if you hit one, but you almost certainly won't. All right, so the little rocky planets are tough targets. But what about the big guys, the giants way out in the outer solar system? Surely our slice is going to hit one of them, right? Let's take a look. So we head out to the gas giants, Jupiter and Saturn, and the ice giants, Uranus and Neptune. And you know what? The scale problem actually gets worse. Yeah, they're huge compared to Earth, but the ocean of emptiness they're floating in is proportionally even bigger. They're just these lonely, tiny islands in an immeasurable cosmic sea. So planets are basically impossible to hit. But what about all the other stuff? The asteroid belt? Science fiction has drilled this image into our heads of this packed, dangerous field of rocks. It is time to debunk that myth big time. We've all seen it in the movies, right? The Millennium Falcon weaving and dodging through this crazy, crowded field of tumbling asteroids. Well, the reality could not be more different. In our actual asteroid belt, the average distance between any two objects is millions of kilometers. It is profoundly, deeply empty. And here's the bottom line. You could fly a spaceship right through the middle of the asteroid belt, and the odds are you would never even lay eyes on a single asteroid. That's just how empty it really is. So, what does this all add up to? When we put all these pieces together, it gives us a completely different and, frankly, a much more accurate map of our cosmic home. This is the big realization from our little experiment. And that realization is this: the solar system is not a busy, packed place. It is, by a massive margin, empty space. A huge void where just a handful of objects are caught in this delicate, beautiful dance, all held together by the invisible force of gravity. And listen, this really matters. It's not just some trivia. Understanding this changes everything. It explains why deep space travel is so incredibly hard. The distances are just beyond our comprehension. It's why actual collisions in space are so rare. And maybe most importantly, it shows us just how incredibly precious, how fragile and unique a world like ours is. It's this tiny, perfect shelter in an unbelievable emptiness. So the next time you picture the solar system, try to forget that neat little line of planets. Instead, picture a vast, silent, beautiful darkness. And deep inside that emptiness, a few tiny worlds are quietly orbiting a star. And one of them is ours.